Hello guys, welcome back, and today we are solving LeetCode problem number 2483, minimum penalty for a shop. In this question, we are given customer logs in the form of an array that consists of the strings y and n. So here we are trying to choose some pointer j, and can be any time from the beginning up until the end of the given log. Also, here they have given a very important edge case which states that j can be equal to n also, which means that j can be out of the bounds of the given array. This is a very important edge case that is to be noted. And then if the shop closes at the date hour, the penalty is calculated as follows. So for every hour when the shop is open and no customers come, that is when shop is open and n is given, the penalty is increased by 1. And for every hour when the shop is closed and customers come, the penalty increases by 1. So in every other cases, like when the shop is closed and when no customer comes, or when the shop is open and customer comes, penalty is not given. So they are asking us to return the earliest hour at which the shop must be closed to incur a minimum penalty. And also, if the shop closes at the j hour, it means shop is closed at the hour j, that is given index. So let's take an example to better understand the question. The given array here is y, n, y. Let me add one more n at the end for better understanding. So what we are going to do here is, let us assume they close the shop at the index 2. So to find the penalty that is being given, we have to calculate the number of n that is coming before the shop is closed. So when the shop is open and no customers come, it is a penalty. So here it is 0, and to calculate the penalty that is after the shop is being closed, we have to calculate the number of y's, because when customer comes and shop is closed, it incurs a penalty. So it will be 1. So when we are calculating the number of y's after the shop is being closed, we have to consider the index from which we are closing the shop to. Because let us take the j pointer is here. So when we close the shop in the third hour or index 2, the shop is closed when the customer comes. So if it was a y here, we would have counted it as a penalty also. So here, if we are traversing through the entire array and trying to find out by going through every index, the time complexity will be O of n square. But let us look at a more optimized approach. So essentially what I'm doing here by introducing a pointer here is calculating the prefix sum here and the postfix sum here. So now what we are going to be doing is storing the prefix and the postfix sum separately. So while calculating the prefix sum, we all know that we are counting the number of n's that is occurring before the j pointer. And in the postfix sum, we are starting from the end of the array and reaching till the j pointer, counting the number of y's along the way. This will take up a bit more space. The space complexity will be big O of n, but then the time complexity reduces to big O of n. So this is a optimized approach compared to the brute force. So here we will be introducing two new arrays, one called the prefix and other is the postfix. I'm naming the prefix as prefix n, and the postfix as postfix y. In the prefix and postfix, I will be including the out of bounds condition, because in the prefix we can close the shop even before the array starts, that is here. And in the postfix, we can keep the shop open till the last index of the array and close it here. So the arrays would look something like, because here there will be no penalty and here there will be no penalty. So how we are going to be calculating the prefix sum is, here there is 0, and since here is y, we still keep it as 0, and it is y here too, so it is still as 0, and then here there is the n. So we write a penalty of 1. And then there is y, so it's basically 0. We migrate this 1 here because 1 plus 0 is 1. And then here there is a n. So it will incur a penalty of 1. So 1 plus 1 is 2. So here from the prefix array, we can see the array is giving us the value of all the possible prefixes for wherever the j pointer is placed. So here we calculate the postfix value similar to prefix, but we start from the last index. So it's 0 here, since it's n here it will still be 0, since it's y here it will be 1, n 0 plus 1 is 1, and y is here, 1 plus 1 is 2, and then another y here, so 1 plus 2 is 3. So these are our final values of the prefix and postfix arrays of the example that we have taken. Now let us try to calculate the final penalty values. So we just add the prefix and postfix values. It will be 3, 2, 1, 2, 1, and 2. Here the minimum penalty is 1. But since there are 2 ones here, we will always use the earliest. That is what is given here. Earliest hour at which the shop must be closed to incur minimum penalty. So it will be in the index 2.
So now let's get the coding. Here we are first initializing a variable n to calculate the number of hours. The closing time can be anywhere in between 0 to n, where 0 and n are both inclusive. Next, we are creating two helper arrays, which is the prefix and the postfix sum. Prefix array counts the number of n's before the ith hour, so that the penalty when the shop is open but no customers came can be calculated. Now we will initialize the postfix array where the number y after the ith hour are calculated, so that the penalty when shop is closed but no customers arrive can be calculated. We are using n plus 1 because closing time can be at the hour of n. So as to find the index, we are using n plus 1. Now we are using a for loop to build the prefix n array. To build the prefix n array, we start from the starting of the loop. That is why I is smaller than or equal to n and I starts from 1. So we copy the previous count and this ensures the prefix sum behavior. Now we are writing a if statement so that when the ith minus 1 hour has n, it increases the penalty count. Why are we using I minus 1? Because if the prefix n of I counts characters before ith hour, we need to enter penalty. So if the shop is open and no one comes, penalty increases. We use the same logic to build the postfix array, but here we are initializing the for loop to start from the last index of the array. So it traverses from left to right and copies the next value to maintain suffix sum. So here in the if statement, if the shop is closed, the customer arrives, the penalty is set to increase. Now to find the minimum penalty, we are initializing the minimum penalty to a very large value, and then we initialize another variable index which will store the best closing time. And then we initialize a for loop to try every possible closing hour. So the total penalty will be equal to penalty when open but empty plus penalty when closed but customers come. So if penalty is smaller than minimum penalty, then minimum penalty will be equal to penalty. That is, if a smaller penalty is found, update the minimum penalty and store closing time will be equal to I. So that's all for today, and thank you for watching.